Hello, everybody. Welcome, welcome. We're going to give it a couple minutes for everybody to join up, and then we'll get going. Ready. For those that just joined, we're going to give it a couple minutes, and then we'll get going here in a second. All right. And our plan is to attempt to take questions as they come in. That may be textually, so we may just respond via text to you. If it's something that's relevant to kind of the topic that we happen to be talking about at the time, we may mention it verbally. If not, we will also try to answer some questions at the end to make sure that we cover down on everything. All right, it looks like we've staying pretty static on the number of participants, so we'll go ahead and get going. Welcome to our presentation to infinity and beyond. And what we're going to be talking about is kind of strategies for actually implementing purple teaming. And so as we start to dig into the webinar, we'll kind of talk about what we mean when we say purple teaming, what we're trying to achieve with that, and then we'll talk about how we can go about doing that. So, Garrett, go ahead and hit the next slide, please. My name is Jared Atkinson. I'm the chief strategist at SpecterOps. I host a podcast called Detection Challenging Paradigms. It's been a little while since we've done that. Luke also hosts it with me, but hopefully we'll get back into that shortly. I have a blog series called On Detection Tactical to Functional, and a lot of the ideas that we're going to be proposing in this webinar come from that. So if you want to dig into a lot more of the technical details on that topic, I really recommend checking out the On Detection Tactical to Functional blog series. I'll go to, I don't know who's next, Luke.
Hey guys, my name is Luke Payne. I'm a managing consultant here at SpecterOps. I go by Versace on most platforms. As Jared mentioned, it says producer on there because I used to be, but now producer and co-host of the Detection Challenging Paradigms podcast. I'm also the co-author of a project called the Defender's Guide that's out on GitHub and Medium. Before I came to SpecterOps, worked as a physical and network red teamer for the California Secretary of State's office doing voter machine certification for their yearly program. I was also part of a company called InfoSight in their threat hunting division and spent a very brief time at Datto as the detection engineer before they sold to Kaseya. But that is me. I'll give it to Garrett.
So Garrett White, I'm a senior consultant here at SpecterOps. Been here a couple years. My background is all blue teaming. So I was a security engineer at a couple places in the financial sector. I was a security analyst in the energy sector. And then I spent the first part of my career as a Windows system admin. I have a lot of hobbies. And those go in and out. So one of those recently is golf, which we'll get to at the end of this presentation. So I will kick it back to Jared and he will get us going.
Cool. Alrighty. So I just want to like kind of give some of you an idea in case you haven't been following kind of our purple teaming philosophy here at SpecterOps. I did a webinar a few months ago where I kind of introduced our method, like our thought process or our philosophy behind what is purple teaming. And so we'll kind of start by talking about that. I started by kind of analyzing what people in the industry kind of referred to when they talked about purple teaming, because it seemed to be like we were talking past each other to some degree. So there's kind of the main themes that I tended to see, or I pulled out of a lot of different definitions that I come across, were that there's this idea of collaboration between offense and defense. So that offense being red, defense being blue, those combined, they make purple, right? A lot of times I found that people kind of stop there. So it's like red and blue should work together to achieve great things. but they left you wondering, like, what are those great things that they're trying to achieve, and how are they going about trying to do that, right? Some organizations talked about increasing familiarity with or understanding of adversary TTPs. Some talked about self-evaluation of existing security posture, so like trying to figure out how well you're actually, addressing the threats to your organization. And then a few talked about improving organization security posture or defenses, and we kind of see things along the lines of preventative controls, detective controls, and response procedures. Okay. All right, so then we came up with kind of what is our definition of purple teaming, and I have this Twitter thread which is linked here at the bottom, where I really go into what we mean when we say purple teaming. The overarching concept is that we're performing the evaluation of security control efficacy through atomic testing using deliberately selected test cases. And this Twitter thread goes into each of those kind of concepts. Like, what is a security control? What do we mean by that? What do we mean by atomic testing, and why do we choose to do that? Why are we deliberately selecting test cases? We're really going to dig into the deliberately selected test cases in this webinar and talk about why that is such a critical component of kind of your purple team approach. But for now, we'll just kind of leave it there. Next slide, please. All right, so what is a security control? This is just kind of setting the stage for what Luke is ultimately going to be talking about a little bit later on. But we kind of broke security controls into 3 different categories. We have prevention, which is essentially, do you stop the thing from happening? So let's say it's curb roasting. The question is, do you stop curb roasting from happening? There's detection, which is you might not stop it, but do you at least see it? Or like, do you alert on it? Do you bring that to some security analyst's attention, right? And then there's observation, which is maybe you don't produce an alert, maybe you don't stop it, but do you even have the ability to perceive that the thing happened in the first place? And so a lot of times, an EDR, for instance, will have the ability to produce an event or generate an event for some action, but maybe that event isn't a component of a detection rule or something along those lines. And so that kind of helps to set the stage. The reason why we're interested in all 3 instead of just one is that we're really thinking about the holistic security posture, which is, for instance, if you detect something, the reason why you're detecting it is so you can later on go and remediate it or address it, right? Prevention kind of does that on its own, and then observation gives you this ability to say, where are we at versus where can we go in the future, right? So if you can observe something happening, even if you don't detect it or prevent it, you might have the capability organically to be able to move forward as you progress. Next slide. All right, so in this presentation, we're going to talk about user hunting, which is a technique that attackers use. If you're familiar with Bloodhound, this was a technique that was kind of a central component of the approach that Bloodhound uses to be able to map attack paths throughout an environment. If you're wanting to reference MITRE ATT&CK, the technique that we think is most similar to user hunting is the T1033, which is system owner / user discovery. This idea, or the name, I pulled from Will Schroeder, one of our colleagues here at SpecterOps' 2015 ShmooCon talk called I Hunt Sysadmins. And so the idea here is that, generally speaking, during the course of an attack or a breach scenario, an attacker is going to change their context constantly, right? So you change the context based on what computer you're operating on. That would be something that we call lateral movement. You also change the context of what user identity or user principal you're operating in the context of, right? And so that would be something like token theft or credential dumping or something along those lines, right? And so the idea here is that as you change your user identity, you ideally are increasing, as from the attacker's perspective, increasing your access to resources. And so that's an important aspect. And so what Will presented during the ShmooCon talk was this idea of, I need to figure out where users are logged in so that I can then target them to steal their identity, particularly, let's say, admins, for instance, right? So you want to know where the domain admin's logged in so you can make sure that you get to that system, and then you could do something like run Mimikatz to dump their credentials and steal their password, and then you could log in and access whatever resources the domain admin has access to. Next slide. All right, so before we get too deep into this, we want to kind of set the stage for what we mean when we talk about procedures. So a lot of you are probably familiar with this idea of tactics, techniques, and procedures, which is TTP. And we could talk about tactics in the context of tactics and techniques in the context of MITRE ATT&CK pretty easily. So we have things like a tactic would be lateral movement, credential access, execution, so on and so forth. The technique is kind of how do you do that, right? So when you're talking about credential access, you could access credentials through Kerberoasting. You could access credentials through OS credential dumping, such as the Mimikatz method, right? There's a bunch of different ways that you could implement the tactical like objective, right? But then we get to procedures, which is like how do you actually do that? Like how do you manifest that within your attack? And that gets a little fuzzy when you're referencing something like MITRE ATT&CK, because there's a question of at what level of granularity are we actually focusing? Our proposal is that it's not what command line did you run, it's not what tool did you use. The thing that's important when you're talking about procedures is this thing that I call an operation chain, which is kind of referenced here at the bottom of the slide. And it's a chain of operations that are used to achieve some objective, right? So a sequence of operations that, when combined, implement a technique or sub-technique. And so at the bottom, I have one example. And this example is an operation chain of kind of the canonical version of process injection, if you're familiar with that. And so what we see is they have to open a handle to a process, and we call that process open. They have to allocate a buffer in memory. We call that memory allocate. They have to write their shellcode, let's say, to memory, the thing that they want to inject into the target process, and that we call that process write. And then they have to execute that shellcode. And in kind of the canonical example, they use create remote thread, the API function, which we call thread create. And so we're able to describe the overarching procedure that implements process injection through this operation chain: process open, memory allocate, process write, thread create. If you go to the next slide, please. The reason why this is important is because we have a tendency to view the world through the operational frame, right? And so I have a blog post in that on detection series, which is linked here at the bottom, where I demonstrate that, especially from the endpoint perspective, what we see are operations. So we have all these event logs that we're collecting. We have EDR logs that we're collecting. And what those are doing is they're telling us about operations that occurred. So a couple examples that a lot of us are familiar with are things like sysmon event ID 10. That's we call that a process access event, but it also it could be referred to as the process open operation, right? So a process opened a handle to another process. You open a handle to LSAS, for instance. We have the Windows Security 4697 event that would tell us about a service create operation. We have a Microsoft Defender for Endpoint write process memory API call event, and that tells us about a process write operation. And so what we see here is we have that same operation chain, that same procedure. And what we see is that MDE actually gives us one event that describes each operation, right? So we see the open process API call event corresponds with the process open operation. We see the NT allocate virtual memory remote API call event corresponds with the memory allocate operation, and so on and so forth. And so the idea here is that the phrase that I like to use is we must align our conception of the threat with our perception of it, right? So it's important for us to start thinking about the problems that we're facing in the context that we're going to observe them, right? And that's this idea that we collect events that tell us about what happened in our cyber world, so to speak. And so we need to start thinking about how attackers do what they do in the context of the things that are being reported to us through those events. Next slide. All right, I'll pass it over to Garrett to kind of talk about the procedures that are relevant to user hunting.
Yeah, so our technique that we're going to go through today is session enumeration or user hunting. And so we took a look at SharpHound, which is the tool we use to collect information and submit into Bloodhound. And it collects session information, or does user hunting, in 3 distinct procedures. The first one being net session enum Windows API. It's part of the session collection, internally referred to as session. Second one is net workstation user enum, and we'll talk about all 3 of these procedures and sort of how they differ. And the third one is querying the HKey users hive, which will return interactively logged in sessions via a SID. So these 3 were talked about. Rohan talked about developing SharpHound in his blog series, where he talked about these 3 techniques. And then the link below is Matt Creel's blog post, where he talks about the tool he was developing, BoffHound, where he looked into these three procedures that SharpHound implements to enumerate sessions on a remote machine so we can submit them back in to Bloodhound. So let's take a dive into the first procedure, which is net session enum. So on the right-hand side, we have the function call graph. And then what this does when you make a call, it returns remote logon sessions. So what that means is, and what we typically do on our Purple team is we'll target a file server. We're not necessarily interested in the file server itself. We're interested in what sessions the file server has open to it. So when we call this API, what that's going to return is IP address and usernames. What that's telling us is this user is logged into this IP address and has an open session to this file server. So when we execute this technique on our Purple team, we target like the most active file server. What happens is we'll get tens of thousands of sessions sometime that come back. And what an attacker will do is conduct user hunting. They will look for, like Jared said, highly privileged accounts like domain admins and try to move laterally to the IP address associated with it. So for this particular procedure, it is implemented. So if you look at the sort of towards the bottom there of the function call graph, you see it makes a NDR client call and RPC procedure. And that RPC server is only implemented via a name pipe. So RPC servers can be implemented via name pipe or TCP or sometimes both. In this particular case, it's only implemented via the name pipe. And if I put my detection engineer hat on, that's really interesting to me because name pipes operate on 445, and I could potentially create a detection for that. So if I think about Sysmon and its name pipe event, or my EDR, does it have a name pipe connection event? Could I detect this with the telemetry that I have? Then the third bullet there is access to this particular RPC server is held in a security descriptor. The blog down there goes into, talks more about a tool called NetSeize. It allows you to modify that security descriptor so you can change who has access to enumerate sessions on the remote machine via that security descriptor. So it gives that NetSeize tool, link below, allows you to enumerate it and also modify it if you want to change it. So in our Purple team, we do this, we run this technique quite a bit. And generally it's authenticated users on Windows Server 2016 and older, and then on older versions of Windows 10. And even some NAS appliances that sort of implement Samba or SMB via Linux will be susceptible to this as well. But in our experience, and then the Compass Security blog talks about this as well, if it's running Server 2019 or newer, or on a newer version of Windows 10 or 11, authenticated users is removed and that security descriptor is actually changed to where you have to be like an admin or power user to enumerate sessions. All right, on to the next procedure. So net workstation user enum. So what this returns, as opposed to not remote sessions or SMB sessions, this returns interactive, service, and batch logon sessions. So interactive is going to be, so if you're familiar with 4624, it's going to be type 10, so like RDP session, or type 2, which is an interactive session, which is generally somebody's at the keyboard. So that's going to be your interactive session, is going to return those. And then services are going to be, if you added an account to run as a service, it'll collect those as well. And then batch is generally associated with scheduled task. Then again, that bullet down there, so if we were wanting to detect this technique, that second bullet there is this RPC server is only implemented via a name pipe. So again, thinking about your telemetry and how you would detect this, port 445 name pipe detection would be awesome to focus in on. So this one has a little bit more restrictive permissions by default. Microsoft's documentation says members of the administrator, server, system, or print operators can view this information, and that's generally what we see on our assessments for this particular procedure. All right, the third procedure is registry key enumeration. So this will return interactively logged on users where their profile is created. So that key is sort of associated with the user's profile. And generally when they log off, that key is deleted. So what this does is it enumerates the H key users hive and enumerates the subkeys, and it will return a SID for each user that's interactively logged on. So it returns a list of SID, and tools like Sharpound will use it like a regular expression to sort of filter out local accounts and built-in accounts. Sharpound or user hunting or an attacker, in this case, will be interested in what domain accounts are logged into the system. So the second bullet, again, this is only implemented via a name pipe. The RPC server is only implemented via that WinReg name pipe. Access on this requires the remote registry service to be running or at least triggerable. So on workstations like Windows 10, Windows 11, that's generally disabled. Although I've seen, and putting my detection engineer sysadmin hat back on, thinking about what GPOs. Do I have a GPO that enables the remote registry on all my workstations? On workstations, it's disabled by default, but a lot of cases, Active Directory, been around a long time. Somebody may put a vulnerability scanner in there that wants to query the registry, and you have a GPO that was created a decade ago that turns on remote registry, and that would allow an attacker to potentially enumerate interactive sessions on all the machines that it could hit on port 445. On the server operating systems, it's set to a trigger start. So services can be triggered to start. And in this particular case, the trigger on this service is interacting with the name pipe. So by default on Windows Server operating systems, if I interact with that name pipe, it's going to turn that service on for me. So it doesn't necessarily have to be running, but if I can hit that port 445, if I can hit that name pipe, it'll turn on the service for me, and I can enumerate, in this case, the H key hive and look for SIDs that are interactively logged on. All right, I'm going to pass it over to Luke, and he's going to talk about measuring EDR capability.
Sweet. All right, so this is kind of an excerpt from a blog I released, I think, 2 weeks ago with the same title of the talk that we're doing today. And essentially, Jared and I were talking about our Purple Team methodology and how we could potentially prove or attempt to prove mathematically that our approach and the way that we believe in building Purple Teams and how we view procedures and each of our individual test cases is the right way, or is, at the bare minimum, a good way to think about it. So when you take a step back and think about the claims that an EDR makes, or that even a security team makes when they build a detection, is typically we detect X, where X is some kind of MITRE attack technique, right? So since this is from a blog post with a different example, user hunting is not on here, but imagine that it was. You have an EDR that says we detect, system user discovery, and there's just a green checkbox, or there's just a statement that they detect that. The question is, how can you quantify what that green checkbox means in a way that's actually usable for you as a detection engineer to build something based off of it? Next slide, please, Garrett. So what we know to be true is, or what we're proposing to be true in our methodology, is that a single technique actually has multiple procedures. So here we have 3 examples of different procedures for user hunting. So we don't really know which one of these, or which combination of these, that a vendor has tested or that a detection engineer has tested their detection against when they're building it. So let's see if we can use my favorite tool in the world, Microsoft Excel. I know that may not have the same reaction with a lot of people, but hey. And see if we can kind of quantify what the potential possibilities are, just assuming that these were the only 3 ways to detect user hunting. And then we're also going to take a step back and say just detection for this example, not we're not going to include observation, and we're not going to include prevention, just to simplify the math a little bit. Give me the next slide. So here we have those 3 procedures for user hunting laid out in a table. And this is, you may recognize it as, like, in a second, as a binary search pattern, or what's known as a truth table, I believe. But every 0 or 1 is a potential state of detection. It's a we detect or we don't detect for each of these. And so each row is a set of potential states that your EDR could be in. And so what's the first thing that we're going to do? We're going to run some kind of test or tests to determine if there's a 0 or a 1. So we're going to assume that for network session enumeration, our EDR does detect it. So that's going to let us eliminate all of the rows with zeros in that first column. So give me the next slide. Boom. So now we've removed all of those. So that is 50% off the bat, 50% of our potential states of our detective capability for user hunting have been taken off the board with a single test. And let's kind of see if this pattern holds true here on the next slide. So now we do a test for logon session enumeration, and our EDR, in fact, does detect that as well. So now we can remove all of the results that have a 0 in the center column, and we've removed half of it again. And now you can see that since there's only 2 rows left, that this is going to hold up if we do another test for registry enumeration of user profiles on the next slide. Boom. So now we're left with one possible result, which is after doing tests to answer whether or not we detect each of those procedures, we have what must be the truth. That's a quote from Sherlock Holmes. Once you eliminate the impossible, whatever remains, however improbable, must be the truth. So that's what we're attempting to do, right? Is to remove possibilities of and unknowns from our EDR's capability and fill them in. And so now we've arrived at a single case where we must detect all of them with our particular EDR. The thing is that this seems like really easy. It seems really obvious, but we can't actually know what the full potential set of procedures are for a given technique. That number is unknown to us because we simplified everything down to a yes or no question for 3 columns. We're able to predict out, how this result is going to end up. But if you go to the next slide, Garrett's typing a response in the Q&A right when I asked him to do that. How can we represent this if we can't truly know the full number of procedures? That's n, and we don't have a way to define n. Now, I'm going to give a little bit of a disclaimer here, which is that I am not good at math. I enlisted somebody who is to help me get a representation of what I'm about to show you. But I am not making a statement that that this is truly the way to define it or track it. It is simply an illustration that I'm trying to use to get the point across here. So show them the curve, Garrett.
If you actually know the correct math, please share it with us so we can be more accurate.
So this is a curve, y equals 10 divided by 2 to the x, which is essentially a curve starting at whatever you put in that first number, so 10y in this case, for ease of math. And it gets 50% closer to the x-axis for every one that x increases. So the way that you could represent this is that first test that we ran took 50% of our potential states off the board. So if you run a single test, you're going to cut down from 10 to 5. And again, this is just a representation of kind of how to look at it. But you can think of the area under the curve as all the potential possible states for your EDR. Next slide, please. So we can't ever fully fill in the curve because we may think that we've knocked out every possible situation that there is for user hunting, and somebody could come up with another way, or Microsoft could push an update that provides a different path to find the currently logged in users for a system. So if we can't do that, all we can do is try and fill in as much of the curve as possible. So here is an example of having run 10 test cases. And so you've kind of brought all your potential states down quite a bit, and it actually looks like you've completely eliminated it. If you go to the next slide. But in reality, that line is not touching. So even if we cut it off at 10 and everything to the left of 10 is filled in, everything to the right, it still doesn't touch, and it's never actually going to touch X. So there is an infinite amount of potential states. And the only way to cut those down is to run as many test cases and eliminate as many procedures as possible to gain data on them so that you can get closer to a representative state of what your EDR can do. And you may be like, Luke, why did I sign up for a webinar to come listen to you tell me that you need to run as many tests as possible in order to get an accurate representation of what your EDR and your detective capability is? I would agree that it is fairly obvious, but it's usually fairly obvious to people when they've been confronted with it, not just in general thought. So there are definitely situations, and I don't know if anyone out in the crowd works for an EDR. I'm not getting after EDR companies for doing what they have to do to make money and to market. But there is a chance that a particular vendor has run one test to claim that they detect user hunting. And that's fine because they're detecting a part of it. But the problem is that you as the end user aren't going to know the test that they ran. And so it's kind of on you if you want to figure out the true status of your EDR to run as many as possible to understand and at least accept the risk that you have for a particular procedure or technique based on how much it can actually detect. So if you go to the next slide. Did I have two with that same picture in it? The next slide. That was an accident. Boom. So this is potentially how you need to think about the claims that vendors are making, or that, again, a security team that has a detection in place for user hunting is also potentially making a claim on too little data. But this is what it could look like, is a question mark of we ran maybe one or two tests and we detect some form of process injection or user hunting or service creation. But they're not going to share that with you and you're not going to know off the bat. Next slide. So you may be assuming that this is how much of a curve has been filled in to generate that green check mark. But reality is it could be only like maybe at best 50% of the potential states. The problem is because our number of potential states can be infinite, if you run one test and that removes 50% of infinity, you still have infinity options left. So you could be in a situation where after 2 or 3 tests, there's still thousands of variations of procedures for a technique that could get past your detection, and you don't know that because you haven't tested enough of them. But the more you test, the more you fill in that curve, and the more you can accept the risk of a particular detection in your organization. Garrett, can you go back to like slide 20 or anything that has the Excel thing on the right? Sweet. So we're going to talk about modalities next. And the thing that you want to focus on for modalities is you have these 0 and 1 on the right-hand side for a particular procedure. And the question is, how do you determine that that result is a 0 or a 1? Is that a single test that you can run? Do you have to run multiple tests to determine that? So we kind of showed that a specific technique has several procedures inside of it. And you may have assumed that to get a 0 or 1 for detection for a procedure that you can run a single test. And what we are about to show with modalities is that likely you cannot.
Before you move too far, can you go back? Sorry, to like 2 more. Yep. Okay. So one of the things that's really important about this, just for sake of understanding, because it may seem a little counterintuitive, is what this is saying is that there are, I mean, how many states are there? There's 8 possible states, right, based on this spreadsheet. And by running, one test or validating that we detect one procedure, that eliminates 4 of the 8 states, which means that we've eliminated 50% of the possible states. That should not be confused with the idea that that means that you have a 50% chance of detecting user hunting if it were to be executed, because they could be running the one state that you don't detect every single time. So what we're doing is we're eliminating uncertainty on which states we are actually in place within our EDR, within our security program. We're not actually talking about the percent likelihood of detecting something. So that's an important distinction to make. But what we're trying to do is reduce uncertainty, and the more uncertainty you reduce, the more likely you are to have a true representation of where you stand in relation to the technique or to the behavior that you're trying to detect. All right. Go ahead, Garrett. All right. So as Luke mentioned, we're talking about ones and zeros, which means that we've collapsed a bunch of information into a binary choice, right? So true or false. And it turns out that it's not quite that easy in reality. And so the key here is that you have kind of like two major variables. This is again talking in the context of detection, but the same thing would be true in the context of prevention or observation. So in observation, you either generate an event or you don't generate an event. In detection, you either fire an alert or you don't fire an alert. In prevention, you either stop the thing from happening or you don't stop the thing from happening, right? So the same binary outcome is true regardless of which of those categories you're dealing with. But what we have the test cases, which are the samples that we're going to execute to try to stimulate some result, and then we have the rule that is being used to basically build the claim, right? So the claim is we detect user hunting. Presumably that means that there's some rule somewhere that is going to produce an alert if user hunting were to occur, right? And so the problem is that there's myriad ways to detect any given test case, right? So for any test case that you choose to run, you could be detecting it in a very robust way, right? Based on the operation chain that we talked about. Or you could be detecting it in a very brittle way, which would be looking at like the file hash or maybe some known string or something like that, right? And so we can't just run one test case, get a binary result of an alert fired, and then say we're good to go, because the problem is we don't have any information that tells us whether or not we're detecting based on the hash of the file that was executed or whether we're detecting on the actual behavior or procedure that was executed. Next slide. All right, and so this became really. I had another slide that was similar to this, but it didn't really fit in this example. But we've seen this kind of transition from specifically PowerShell to other programming languages. So at first it was from PowerShell to C#, and now it's a lot more popular to go from PowerShell to like BOFs or beacon object files. And what we saw is that there was a blog post that came out to announce a bunch of features in PowerShell called PowerShell Loves the Blue Team, and that's when they released things like script block logging, AMSI support. There's a bunch of security elements that they introduced into PowerShell that made operating within PowerShell more dangerous for an attacker from the perspective of the likelihood that you would be detected, right? And so attackers took that information and said, okay, well, I could do the same thing in a different language. And so they for instance, you would go from a tool called out minidump to a tool called sharp dump, where they just ported out minidump, which is a PowerShell script, to C#, and it would do the same exact thing. We see the same thing happen here, where there's a popular PowerShell tool called PowerView's getNet session. That's a PowerShell function. And what that would do is that would do the first user hunting procedure that Garrett introduced, right? That net session enum. And the problem is that because it's written in PowerShell, PowerShell has a lot of visibility, and that made it very easy for defenders to kind of like detect that behavior. And so what happened was somebody made a change to where they ported the getNet session into a beacon object file, and that removed that PowerShell dependency, and then changed the results of our detection capability. And so that's something that we should pay attention to. It's like I made a minimal change to just the language in which I wrote my tool, and that caused a change from a 1 to a 0 from my perception of my ability to detect it. Next slide. All right, and so what's interesting is we can take that same function call stack that Garrett introduced, right? This is net session enum, and it goes down to that network session enumeration operation. And we could take a bunch of different tools and we could plot them in the function call stack or relative to the function call stack. And so, for instance, we have a built-in console application called net.exe, right? So you might be familiar with the session command for net.exe. An interesting aspect of that is that it actually only has the ability to look at local sessions, not remote sessions. And so it's not super useful from an attacker's perspective, but it is calling that same function, that net session enum function. We could look at netsesh.exe, which is a third-party console application that's well known, right? And so an attack or a defender might detect netsesh.exe based on the name because it's a well-known tool, right? So you might have where process name equals netsesh.exe or something like that. We have a PowerShell script, PowerView's getNet session. We have a C# tool, which is sharphound. It's not actually plotted in this picture, but it would also be along that top line there. We have the beacon object file, so getNet session, the getNet session BOF. And then we have Impacket has a tool called netview.py, which also implements the same functionality, but it does so at the RPC layer. So it skips over all the API functions and does it at the RPC layer. And so what we find during our purple team is that if you only run one of these, let's say you run PowerView's getNet session, you might get an alert. And if you assume that that alert means that you detect the behavior, you're in for a rude awakening because based on our experience, it is significantly less likely that organizations and or products detect the BOF version of the tool, of the procedure, than it is that they detect the PowerShell version of the tool, of the procedure, sorry. And so what we're saying is that there tends to be a bias in our security controls towards tool implementations rather than behaviors, okay? And so if we go to the next slide, please, we'll go to a little example. And so we're going to break this down into an example of why this is. And I have a blog post that I wrote about this in that on detection series. And what we're going to do is we're going to look at PowerView's getNet session. This was written by Will Schroeder, Harmjoy, in 2014. And it uses what I call the execution modality type of PowerShell script, right? And as we see, this is an excerpt from the actual code of PowerView's getNet session. And we see that it calls a function there at the bottom, net API 32 net session enum, right? So just keep that in mind. The other aspect that's important is that second line there, you see $query level, and that's set to 10, right? That's the specific like information level. So what information do we want the function to return? You go to the next slide. We see a second sample, which is the beacon object file getNet session. This is part of TrustedSec's situational awareness BOF project, and is written by Christopher Passion in 2021. So we see that there's a few years that getNet session from PowerView actually worked, and then PowerShell became highly scrutinized and became less advantageous for attackers. And so then there was this move from PowerShell to C#, and then there was a move from C# to beacon object files, basically. And so we see, if we look kind of down there at the bottom, the part that's highlighted, we see again, net API 32, net session enum. So these two functions, or these two tools, are calling the exact same API function. We also see probably about the fifth line there, we see dword DW level, and that's set to 10. That's the same information level that we saw in the previous tool. And so we see that these are essentially doing the same thing, right? They're literally doing the same thing. The major difference, and they actually literally have the same name, right? So this one's called getNet session, and the other one's called get-net session. So they have the same names, same name. They're doing the same thing. The major difference here is the language that they're implemented in. And actually, as I dug into this, I found out that the language isn't actually like the major factor. The major factor is the mode of execution, right? The modality, which is, it could be a PowerShell script, it could be a console application, it could be a beacon object file, it could be a direct RPC request. There's a bunch of different modalities that are available to attackers as a form to actually execute a procedure. Next slide. Now what we're going to do is I'm going to take two Sigma rules that are live in the Sigma repository. And this is not meant to like denigrate the Sigma rule that performs worse. There's value in detecting like highly targeted detections, right? So this first one is going to be highly targeted. The second one's going to be more generic. There's a trade-off there, right? And so it's not saying one's better or one's worse. They just do different jobs. But I'm trying to use it as an illustrative example. So this first rule is called malicious PowerView PowerShell commandlets, and is written by Bhavesh Raj. And what I like to do when I look at these rules is set up a set of conditions that must be met in order to fire an alert, right? And so the first condition is that PowerShell script lock logging is enabled, right? Because we don't actually have a real environment that we're doing this in, we're just going to assume that that's true, right? So everything will pass that condition as we start to dig into it, both of our samples. The second one is that the tool is implemented in PowerShell, right? Because in order to trigger PowerShell script lock logging, you have to be executing PowerShell code. And then the last one we see on line 29 is that the script block text contains getNet session, right? The real rule has a bunch of different strings there. I just, for kind of brevity's sake, selected one string. But we're looking for the term getNet session. And that's based on the fact that PowerView's getNet session, that's the name of the function. And so it's going to detect it that way. Next slide. And then we have the Sharphound recon sessions. I'm going to probably butcher these names, but written by Sajid Dolce, and Decalpaz. And they're using something called RPC Firewall, which is, I believe, something that Sajay Dolce wrote. Maybe Decalpaz also wrote RPC Firewall. But this is the ability to basically monitor and or block RPC requests at a host-based level, right? And so again, because we're talking about a hypothetical environment, the idea is that if you built a detection rule that relied on the RPC firewall, we're going to just accept the idea that you probably have the RPC firewall set up properly, right? And so we'll say rule or condition number 1 is going to be true. But the second condition is that the RPC interface that we're seeing is this on line 25, 4B32, 4FC8, so on and so forth. That refers to the Microsoft Server Service Remote Protocol, or MSSRVS. And then the third one is that the procedure is opnum number 12. That's line 26 there. And that refers to the netar session enum RPC procedure. Okay. And so assuming that those 3 conditions are met, you would presume that an alert would fire. If you go to the next slide, Garrett. And so what we're looking at here is we have this table, and there's 2 primary variables. There's the rule that we're looking at and its associated conditions. And then there's the samples or the test cases that we're executing. And so generally speaking, the purple teamer does not have only has control over the sample, not over the rule that's being used, right? So we're not creating the rules, we're evaluating the rules. And so what we're doing is we're selecting a set of samples or test cases that are going to help us glean information about the rule. The reason why I say glean is that in this case, we actually had the explicit rule, so we could look at the rule and evaluate it and pull out what the conditions are. A lot of times with EDR products, the rules are going to be proprietary, or they're going to be kind of like a black box, and so we won't know what they actually do. And so what we want to do is we want to design a set of test cases that allow us to evaluate or glean what are the conditions that must be met in order for this rule to fire, right? And so what we do is we hypothetically run samples 1 and samples 2 in an environment where rule 1 is applied, and then in an environment where rule 2 is applied. And we see that rule 1 is going to detect sample 1 because sample 1 meets all of the conditions. But sample 2 does not meet the second condition, which, if you recall, is the condition that the tool is written in PowerShell and therefore would trigger PowerShell script block logging. On the other hand, we have rule 2, and when we run sample 1, it passes all the conditions. And when we run sample 2, it also passes all the conditions. And so that means that in an environment where rule 1 is the rule, so again, we don't know what the rule is. We just are being told we detect user hunting, right? And we're just taking that as kind of as a statement of faith, right? So we detect user hunting, trust us. Well, what if they detect user hunting using rule 1 instead of rule 2, right? We're going to have a different result at the outcome. Next slide. All right, so we could actually take our rules and our samples, and we could overlay those again onto our function call stack. And so as we do that, we notice that rule 1 is going to be dependent upon the execution modality, right? And so that's pointing, rule 1 is up there in the top left, and it's pointing to sample 1 because it only addresses the context or the modality that sample 1 is implemented in. Rule 2, on the other hand, is down there at the bottom of the function call stack, and it's specifically focused on the RPC procedure call. And so the idea here is we use this function call stack to understand the different entry points or the different functions that attackers have access to in order to implement a procedure. And we see that no matter how they choose to implement it, they're always going to call that RPC procedure. And so that means that rule 2 is a more foundational level detection, and therefore is going to be more comprehensive in its ability to detect this procedure, this particular procedure, right? But what we want to do, especially in cases where we don't have access to the contents of the rule or the actual algorithm that's being used, is we want to choose samples that exist at different levels within the function call stack, and also implement different execution modalities so that we can begin to kind of discover, right, what are the conditions that this rule is implementing, and then where does that fall in the stack, and how much confidence does that give us that if this procedure were to be executed, we would actually get an alert. Next slide. Go ahead, Garrett.
All right. So we just talked about 3 distinct procedures. So category 1 being the procedure. We talked about 3 of them for user hunting or session enumeration. Jared talked about execution modality, which is varying between a PowerShell script, a BOF, or proxied execution. And our third category, the way we classify our test cases in our runbook, which we'll go through here in a minute, is minor variations. So it's the same function chain, but different variables. So generally, when we conduct our purple team, these are environmental factors. So we'll, like process injection, we'll alter the payload. Maybe it's a shellcode or a DLL. Maybe that payload's a beacon versus a benign calc shellcode. We'll alter the target user, computer, process, depending on which technique we're executing that day. For session enumeration or user hunting, we generally change the target host. So we'll try to enumerate sessions on a workstation. We'll try to enumerate sessions on a file server. And generally the file server, like I talked about, will get back thousands of sessions, especially in the NetSession enum, where it's looking at SMB sessions. And if you have a really popular file server where everybody has a bunch of mapped drives, that's the most value for an attacker. What we also do in our purple team is we ask the organization for a machine that we're, quote unquote, not supposed to get to. So they'll give us a machine on a different network segment or give us a workstation on a different network segment, and we'll test against that machine. Can we enumerate sessions across some boundary you think is there or should be there? And then sometimes we have success. So they'll give us a file server. It's like, yeah, this is on a different segment. You'll never hit this file server. And turns out their segmentation's not implemented in the way they thought. And we, get back a ton of sessions. So that's how we use minor variations in user hunting. Other techniques, this might be curb roasting. We'll use this in curb roasting. We'll target a single SPN versus all SPNs. So like Microsoft Defender for Identity is really great when you target all SPNs, but if you just target a single SPN, and we sort of hunt around for those in our purple team, highly dependent on the environment. So we look for passwords that are extremely old, we look for accounts that are highly privileged. And sometimes that's a honey account. We've encountered that on our purple team. So we curb roasted a honey account. The client sent us to it and they were really proud. They should be. That's awesome. I love deception technology, but we generally hunt around for those single SPNs and alter what SPN or account we attempt to curb roast. And then the last bullet there is process injection. Like I talked about, we alter the payload, shellcode, DLL versus maybe a beacon, something that's actually malicious or attacker might use, or we'll do something like calc or notepad, something benign, and alter it that way. All right, so we have our three categories that we put in test cases when we create a runbook for our purple team. So this is where we talked about a lot of theory and categorization. So this is where sort of the rubber hits the road. What test cases, how do we conduct our purple team? What do we use? So like we've talked about, we create a diverse set of distinct procedures which use a variety of execution modalities. So these are designed, the three things that we look for when we run each individual test case is whether it was prevented, detected, or observed. So prevented being maybe a host-based firewall, or maybe EDR kills it, or maybe you have like a Palo Alto checkpoint. Detected, meaning to us, is there's some alert that's triggered that a human's going to look at. And then observed is there's some sort of telemetry that could be used to create an alert that's centralized. Generally, this is in the organization's SIM. So what we do is we use a numbering system. So the X, the first number there, is going to be our distinct procedure. We talked about the three: NetSession enum, Net Workstation enum, and reg query, reg enumeration. Then our Y there in the test case is going to be execution modality. It's going to be PowerShell, BOF, proxy execution. And then Z, just like I talked about on the last slide, that's going to be our minor variation. So in the case of user hunting, we're going to alternate what machine we target, either across segments or type, workstation, or servers. So let's go through some of these test cases. So for distinct procedure 1, we created a sample runbook here, and we'll actually go through an example runbook we created for this webinar for this technique. So test case 1.0, we see the only variation here is execution modality. The distinct procedure stays the same. We just change between a NetSesh on disk to a BOF to PowerShell to impact it. So that's our variations here. And then like for test case 1.2, we So we don't use like static runbooks. We alter these quite a bit based on the user environment. Like I talked about that minor variation. We use that quite a bit based on the user's environment. We'll also use execution modality in the user's environment. If they just outright block PowerShell.exe, we're not going to run 50 test cases that attempt to call PowerShell.exe. A lot of variation of PowerShell. We'll try in memory. We'll try unmanaged PowerShell. We may try to patch out AMZ and add some additional test cases, or sort of have a menu of test cases that we use where we change a lot of variables based on the sort of tailor it to their environment and what controls they have in place. And then the last one is a SOX proxy. So a lot of C2 frameworks like Mythic or Cobalt Strike will allow you to start a SOX proxy and run thempacket script on your attacker workstation, so where it just creates that RPC traffic. So distinct procedure number 2, again, we have some varying test cases. We have 3 different execution modalities and 1 slight or minor variation where we're calling a workstation versus a server. Again, we just alter this, highly tailored to the user's environment or the environment that we're operating in, and we alter between a BOF and then a workstation, a server, impact it again, we proxy execution, and then PowerShell. So for the third test case, again, same sort of thing. We have 1 variation here between BOF and impact it, where we alter the execution modality, and then we alter between a server and workstation, where we run the reg query BOF that enumerates those keys and returns some SIDs, and then same thing with Python. All right, so we're going to do a demo here. So we created a runbook here, and if you go to that link at the bottom, it'll take you to a GitHub gist, and it'll have an example runbook that we created for this webinar for our Purple Team assessments. This is very similar to what we do. So this is a TOML file, it's structured format. So for somebody who asked the question whether we use vector, we do use vector on our assessments, and we keep a lot of our test cases in a TOML format, and we insert those into vector. The TOML, the structured format, allows us to also interact with C2s like Mythic or Cobalt Strike. It allows ease of reporting. So we take the structured format, we could even execute test cases, we can report on it, and we can insert it into like a Purple Team tool like Vector. So this particular runbook that we created is using all free or open source tools. So these commands and these test cases will work with Mythic and Apollo. So Mythic being the C2 framework, Apollo being the agent. So we have the execution steps there. So you could take those commands and actually plug them into Apollo running on a Windows system and execute this same set of test cases that are in this runbook. So I'm going to switch over. If you want to follow along, just plug in that link. And yeah, Luke put it into chat. Thank you. And Jared. Plug that link into your browser, and I'm going to switch my share, and we will look at this runbook together. All right, so here we have our TOML file, and we have a few things here. So we have the test case number. This tells us, as we talked about, the numbering system, distinct procedure, execution modality, minor variation. So in this particular, we're going to upload the netsesh.exe. Again, when we see this on our Purple Team, a lot of times this gets immediately deleted by the EDR because it's malicious. And then so by the time we go to run it, we get a file not found. So if we go to next test case, we alter the execution modality. This time we're running a BOF, and we have links to the tools that we use for this. Again, all free and open source. You can get Mythic up and running, install Apollo, and run through this test case yourselves in your own lab or your own environment. So for a BOF, in the case of Mythic, we register the COF or the beacon object file, and then we execute it and call these functions. And then we have some placeholders for which particular minor variation that we're going to change in this case, so we can plug in a file server or a workstation if we want to enumerate sessions laterally. And then 1.2 here, again, execution modality. This is PowerShell. In this particular case, again, PowerShell has a ton of variations. In this example we're just uploading the PowerShell script and then invoke expression to basically import that function and then calling the function that we imported. And then we have our host name placeholder there in our runbook. And again, all those test cases in the slides we have put in here with exact steps. So here's an example of SOCKS proxy. So in this particular case, we run SOCKS 7005. What that's going to do is send that port back to our Mythic server. And then we can tell proxy chains to listen on 445 for proxy traffic. We're going to send that RPC traffic via Python over that 7005 port and enumerate sessions. And we get placeholders for domain username, password. Since we're not operating in the context of our beacon, we're back on our attacker machine. This requires plain text creds. All right, I'm going to switch back to the slides, and Luke is going to talk about golf a bit. Let me get back here. There we go.
All right. So this is, I want to frame this correctly. This is our idea over the past couple of weeks of me being very into golf, Garrett being very into golf, and Jared being dragged kicking and screaming into golf by one of our other vice presidents. So I was kind of thinking of how we could make the results of our purple team more useful for customers, because there's a bunch of potential differences in results there. And then if you hand somebody like a 10 out of 15 test cases got detected, it doesn't really give a good explanation of if that result is really good or bad. So we provide that number to our clients, but I suspect most of them just read through each individual result to get the context and kind of gain what they need. So those 5 test cases that weren't detected out of that 15 could in reality be, one, very difficult to detect even via custom detections, or the EDR being tested could actually have no functionality in order to provide telemetry for that specific test case. So next slide. So welcome to golf, where handicaps are made up and the number of strokes don't matter. So there's kind of a concept in golf of a handicap, and most people have heard that term, around the golf course or around life if you have someone that plays golf. But there's actually several categories of a handicap. So there's a playing handicap and there is a course handicap. So your playing handicap is you versus the other players that are playing on that course. So it's you competing with everybody else. It's your course handicap multiplied by the handicap allowance of that course, which is usually a percentage, and it will cut down your handicap. So this results in a lower handicap that indicates that you are better, which makes beating other players more difficult. Follow along with me. And then there is a course handicap, which is just you versus the course and the course's rating. And this is typically higher than your playing handicap, which a higher handicap means you are worse at golf, but makes the game of golf easier because you get more strokes back. So just don't worry about that too much. It's just a golf explanation. Next slide. So in terms of scoring your EDR capability, we could have you versus the course and you versus other players and give you a snapshot of the number of test cases prevented, detected, and observed versus the default configuration of the EDR that you have installed with no changes, just a blank slate. You will typically score better on this versus the course than you would score versus other players. So this is just you competing with the like base level of, let's say, MDE. Then you versus other players is your score versus every other person that SpecterOps has done an engagement for that has the same EDR capability. And so likely you will do worse versus these other players than you would versus just the course or the blank installation of the EDR. Next slide. So then we could give you a quick snapshot of, are you over par, under par, and we could come up with non-golf terms for non-golf people. But essentially, if you are under par versus either the course or the other players, you've somehow disabled default features of the EDR. Your operating system configurations are making you more open to attack. Potentially, you've manually enabled RC4 for curb roasting. You may have exclusions that are too broad in your custom detections. You're not logging your third-party tools or firewalls into your SIM to make them useful for detection engineers. You may not have custom detections. All these things could be contributing to you having a lower score than average versus a blank installation or versus other customers. And then if you were over par, that means you've enabled non-default features like removing SE debug privilege from standard users. You've used configurations like LDAP signing to strengthen your security posture, or you're completely blocking WMI communication between hosts with a third-party firewall or some other tool, and you have custom detections in place. Next slide. So I know that golf is kind of a weird thing, but to use, but I felt like it kind of explained it correctly. Believe it or not, I saw a TikTok that explained the handicaps that way and gave me the thought. But my theory is that the literal scores of X number of test cases out of X number of total test cases is likely not that useful. And using this kind of over par, under par methodology versus you and versus other customers and versus the EDR could just give you a quick snapshot of your posture of like a thumbs up, thumbs down, and kind of highlight if you have a particular test case that you're under par on. You could kind of zoom in on it real quick and make changes, because you would kind of get a equal with par or above par score on something that your EDR doesn't have capability for. So you could kind of not throw away, but deprioritize that particular test case because your EDR doesn't have the functionality you need in order to effectively detect it. And you could zoom in on the ones that other people are using your EDR to detect and kind of fix those up quicker. So let us know in the Q&A if you think that that makes sense, or you think that that would be a good thing to add. This is kind of where we wanted to ask the question and toss out a theory we've been having on scoring in general for Purple Team assessments. Cool. With that, we are at the end of our scheduled content. I'm sorry we held you hostage for an extra 8 minutes, but if you have any questions, feel free to toss them in there. Yeah, Tim. So he said, here, if I hit answer live, does it show it? I really like the golf analogy. It's something that I've been encountering too, and it's tricky. I feel like the real question they want to know is more around, is this an us problem or an industry problem? That's essentially what I'm trying to get at. If you're below par against other customers, it's probably a you problem. But if you're below par, all the other customers are below par, and you're above par on the EDR, then it's likely an industry problem. So I know I keep saying par a lot. I got to come up with different terms to kind of theorize this and make it professional enough for a report. But that's kind of the idea I'm getting at, is we get asked that pretty often. Like, is this specific to us? Are other people solving this somehow? And I want to give them a snapshot of that in our reports.
Another thing to take away, this is maybe not particularly something that like people feel like they should need to pay for, but one thing that I think, if it is an industry, so it is to some degree an industry problem, like 100%, so that there's no doubt in that. But one thing that we want to do is use this as a mechanism to educate the industry of the problem and give them like technical examples to where they could actually point, like it's not just a feeling, but you have like hard data to support it. Because as a consultancy, it's a little bit more difficult for us to get those changes to be implemented, because honestly, we're not buying EDRs, and even if we were, we wouldn't be paying the same amount that everybody else would be paying. But like bigger organizations potentially do have the ability to impact the roadmap of these products, and so as they begin to see where the like kind of industry problems are, they could potentially exert pressure to make the changes that we actually want to see. So that's part of the thought process anyway. It's these are definitely like, we definitely have not reached the limit of our ability in the context of detection and prevention. So there may be certain edge cases that we can't solve at some point. We're 100% not there yet. And so, we just need the proper incentive structure to get people to change their approach to try to address that.
How do you define time set deadline for purple team activity? Is that the same all the times? Are you asking like when we're doing an engagement, how long do we give them to tell us that they detected or they found something?
I think if I understand it correctly, it's just kind of like what time do you execute your test cases? And I think the answer is that we haven't actually considered that, to be honest. We just do it during work hours, essentially, or whatever like the predefined time frame is that we're going to execute the assessment. So during our customer organization's work hours is when we test it. That is it's potential, like I would say it's probably not going to have a huge effect in most cases, but it could potentially um, matter. So it's something to consider. I would say that probably has a bigger impact on the response component of things. When we're doing a purple team, maybe something that's worth pointing out is that we are specifically addressing the technical capability, right? And so let's say you have an alert, and then there's a question of, well, what's the efficacy of your process to handle that alert and then remediate the activity? That is outside the scope of what we test during our purple teams. That doesn't mean that you can't have a purple team approach to that, although that is actually a question that I think a red team is probably better poised to answer personally. Um, so like one of the big problems I think with how we approach solving this question of like, do I detect X, is traditionally we've tried to use a red team approach for that. And the problem is that the red team approach simply does not provide the data that you need in order to answer those questions. And so we've been basically prescribing the wrong process to answer that question. And so the red team approach is probably the right approach to try to answer those how does my response process work questions.
Yeah, and on the other aspect of timing is we space the test cases out because a lot of EDRs exist in the cloud, so there's generally a delay to when you get an alert or you get some telemetry. We also alter what host we're executing the test case from, so we'll ask the client for a couple hosts, and we'll alternate. So we'll do one on one host, two on another, and space those out so they can distinguish between the test cases, between the alerts and the telemetry they see based on like the PID, the user, the machine we're executing. And we generally do about one technique per day. So we're not just spamming test cases and hoping you detect and sort of sift through all the telemetry. We try to space them out so you can like sort of atomically identify whether it was alerted or was observed.
Cool. Alrighty. Well, pending any other questions, we thank you for your time. Thank you for joining us. Feel free to reach out to any of us. Somebody asked whether or not the recording of this webinar will be available. That will be available on SpecterOps' YouTube channel. I don't know what the time frame for that is, but let's say a week from now. And then the presentation, the slides, will be available on SpecterOps' GitHub page, I guess, GitHub organization, and that will be available probably by the end of the day so that people can do it. If you follow me, Luke, or Garrett, we will tweet those out so that you can find them more easily once they get put up. So thank you for your time. If anybody has any other questions, feel free to drop them now. Otherwise, you could also reach out to us on Twitter, in the Bloodhound Slack, on LinkedIn, wherever you want to reach out to us. So thank you, everybody, and thanks for the great questions.